The Cold War was an era defined by an existential dread, a relentless technological arms race fueled by fear and ideological division. Nations stood poised on the brink of atomic annihilation, each seeking an insurmountable advantage, a decisive deterrent that would render any adversary powerless. This desperate quest for supremacy pushed the boundaries of human ingenuity and at times plunged deep into the realm of the unthinkable. Conventional warfare transformed into a crucible of radical concepts where the sheer audacity of an idea often superseded practical limitations or even ethical considerations. In this fervent climate, military strategists and scientists conceived of machines of such immense and destructive potential that they seemed to defy the very laws of physics and sanity. They envisioned instruments of war designed not merely to deliver a payload, but to become an apocalyptic force in their own right, a persistent threat that would shatter the foundations of civilization. It was a period when the lines between defense and annihilation blurred, giving rise to projects that remain, even decades later, both astonishing and profoundly disquieting. One such endeavor, born from the crucible of this atomic age, was a weapon that aimed to harness the raw power of a nuclear reactor, not for electricity, but for thrust, transforming a missile into a terrifying, ceaseless harbinger of doom. In 1957, as Sputnik orbited the Earth and the nuclear standoff intensified, the United States Air Force initiated Project Pluto. Its objective was the development of the Supersonic Low-Altitude Missile, or SLAM. This was not merely another cruise missile. It represented a radical departure in propulsion technology and mission profile. At its core, SLAM proposed to use a nuclear-powered ramjet engine. Unlike conventional jet engines that rely on burning fuel, the Pluto engine would derive its power from a small, unshielded nuclear reactor. Air would be rammed into the reactor core, superheated to extreme temperatures by the fission process, and then expelled at high velocity, generating immense thrust. The advantages of such a system were immediately apparent and horrifyingly potent. Without the need for bulky chemical fuel, the missile possessed an almost unlimited range. It could fly for extended periods, at supersonic speeds, at altitudes as low as 1,000 feet, beneath enemy radar defenses. The mission profile envisioned was unprecedented. Launched from friendly territory, SLAM would fly across oceans and continents, delivering multiple thermonuclear warheads to various targets within enemy territory. After deploying its ordnance, it would not simply crash. The missile was designed to continue flying, potentially for weeks, its unshielded reactor spewing radioactive exhaust over vast swathes of land, transforming the weapon into a persistent, airborne doomsday device. Lawrence Livermore National Laboratory was tasked with the development of the reactor, while the Vought Corporation focused on the airframe. The engineering challenges were formidable, encompassing extreme heat resistance, radiation containment for ground crews, and the development of specialized materials that could withstand the operational environment. This was a weapon designed to terrorize not only with its payload, but with its very existence. The theoretical promise of Project Pluto gradually transitioned into tangible engineering milestones. The most critical component, the nuclear ramjet engine, required rigorous testing. A specialized facility was constructed at Jackass Flats within the Nevada test site. Here, the reactor prototypes, known as Tory IIA and later Tory IIC, were subjected to full power tests. On May 14, 1964, the Tory IIC reactor was operated at its maximum design power for 5 minutes, simulating actual flight conditions. The success of this ground test was profound. It definitively demonstrated the feasibility of operating an unshielded nuclear reactor as a propulsion unit for sustained supersonic flight. The air emanating from the reactor during these tests reached temperatures exceeding 2,500 degrees Fahrenheit, emitting a powerful roar that could be heard for miles. the operational implications of a fully realized SLAM were stark. Imagine a missile traveling at Mach 3 just above the treetops, emitting a continuous plume of radioactive exhaust. Its passage alone would render wide corridors of land uninhabitable. The missile, unofficially dubbed the Flying Crowbar, due to its robust design and the sheer destructive force it represented, was intended to be launched in times of extreme global conflict. Once airborne, it was unstoppable and virtually uninterceptable. After delivering its primary payload, the missile would continue its trajectory, circling above enemy cities, its reactor radiating intense heat and deadly particles, ensuring widespread contamination long after its conventional warheads had detonated. This was not merely a delivery system. It was a psychological weapon designed to inflict an enduring and inescapable terror. The very concept, while technically validated, began to highlight the unprecedented environmental and moral quandaries inherent in its deployment. The success of the reactor tests paradoxically underscored the immense peril a deployed SLAM would represent, not only to an adversary, but potentially to global ecosystems. Despite the technical triumphs achieved at Jackass Flats, Project Pluto was ultimately canceled in July 1964. Several converging factors contributed to this decision. Foremost among these was the rapid maturation of intercontinental ballistic missile, ICBM, technology. ICBMs offered a swifter, more predictable, and arguably more secure means of delivering nuclear warheads to distant targets. They traveled at extreme altitudes, minimizing environmental impact, and their trajectory was calculable, allowing for more precise targeting and greater command control. Submarine-launched ballistic missiles, SLBMs, further augmented strategic deterrence capabilities, providing an undetectable second strike option. The inherent dangers of Project Pluto were also a significant concern. The concept of a nuclear reactor flying at low altitude over land, whether friendly or enemy, presented immense safety and environmental risks. An accidental crash, a malfunction, or the continuous release of radioactive material from its exhaust plume raised insurmountable questions about global contamination and long-term ecological damage. The logistics of testing such a missile, which would require an isolated test range stretching for thousands of miles over an ocean, proved impractical. The ethical implications of a weapon designed to persist as a radioactive menace long after its conventional mission concluded also weighed heavily. Project Pluto stands as a stark monument to the audacious and terrifying creativity unleashed during the Cold War. It was a technological marvel that pushed the boundaries of engineering, yet it also illustrated the self-imposed limits on weaponization when the destructive potential became too vast, too uncontrolled, and too dangerous for humanity itself. Its cancellation marked the closure of one of the most extreme chapters in the history of military innovation.